Good morning, children. Now, today I am going to teach you the left portion of the carbon compounds. In this, the portion which is left was during our offline classes were the cycloalkanes. Now, how to prepare cycloalkanes? Alkanes, you know very well, it is a compound having a saturated hydrocarbons. Now, when the word cyclo comes, cyclo means having a ring structure in it, then in that way you will come to know that cyclic ring has to be will be formed. The general formula which you have to write here is CnH2n. Using this formula, we can write down the cyclic structure. You will always keep it in mind that there is always 2 hydrogen less than the normal alkanes in cycloalkanes. Here we will see the example propane. We will have to start from the compound propane, as because 3 carbon only can form a cyclic compound, not the 2 carbon or 1 carbon. So propane general formula is C3H8, and when we write down cyclopropane, you will find that the amount of hydrogen is 2 less. So in this way, the triangular structure which will form having 1, 2 and 3 carbon in it and 6 hydrogen, each carbon is having 4 bond. 2 bond is attached with the during the formation of the ring, and the rest 2 is present outside in the form of hydrogen bond. So in this way, cyclic ring of 3 carbon is obtained, forming cyclopropane. Similarly, you can prepare for cyclobutane. Here also you see there is 2 hydrogen less than that of normal butane. For 4 carbon, you can arrange a square structure. Now for pentane, cyclopentane having a pentagon structure. For cyclohexane, you will get a cyclic similar to that of benzene, but benzene is having 1 single and 1 double bond. It is not that. You will have the hexane structure in the form of a ring. So this is the cycloalkane compound. Now next topic which we will have to study, a general introduction, only the general introduction about the functional group. Now this, though it has been deleted from your course, but simple one introduction part you should know about the functional group. Now what is functional group actually? An atom, like suppose this is an atom, halogen having a single atom, or group of atom like OH, CHO and C double bond O, like this atom or group of atom, when replace one hydrogen, when it replace one hydrogen of an alkane and get attached to it and give its property to the alkane. Alkane has lost its property. Alkane will lose its property as soon as the functional group attached to it. We can see the example here. You can 3-4 examples I have written, children. For when we talk about when the functional group is halogen, that is H, we will represent halogen with the point with X, and this is known as halo group, in which instead of X we can write on fluorine, chlorine, bromine or iodine. Okay, you don't have to write the complete formula, but you have to write down the symbol for fluorine, chlorine, bromine and iodine. In this, the word that you will use will be halo as a prefix. If we want to write down the alcohol structure, we will use OH. The suffix OH will be the functional group that is attached to the hydrocarbon. I will show here with the example also. And the suffix used will be OL, or you can say it all. Aldehyde, we use the functional group CHO and the suffix used is al. For ketone, the functional group is C, that is 4 bond of carbon, C with a double bond O, and one is the suffix. For carboxylic group, COOH is the functional group and the suffix used is oic. For this year's course, only this much introduction is sufficient. Now how this functional group get attached? You can see the general formula CnH2n plus 2 for the alkanes. In this alkane, one hydrogen has been removed from this alkane and in place of hydrogen OH is being attached. So the general formula will become CnH2n plus 1. Instead of 2, one hydrogen has been given out and in that place OH has been attached. Now we will take another example like methane. CH4 is a methane and this removes one hydrogen of methane is removed. It will form methyl that we have already discussed, and in place of that hydrogen OH is attached, so you will get methyl alcohol, or so IUPAC name will be methanol. Meth means one carbon, all that is suffix we will use it as alcohol, so we will now name it as methanol. Similarly, when we'll use another compound ethane and removing one hydrogen and replacing it by one alcoholic group, you will get ethanol. And suppose we are using halogen, we will get haloalkanes like chloroethane or bromomethane, whatever. So this much up till here is this much is required for as a functional group for 10th class course. Now we are going to study little about halogen homologous series. You can see here, children, I have written some points for homologous series. Though what I have written and what I am going to explain, listen to it very carefully. Homologous series means series that we follow while writing the names of the compounds, which we have already studied, children. See, alkane. When we see the alkane, use the general formula CnH2n plus 2. And using this formula, we get one series of methane, ethane, propane, butane, pentane, hexane, like that. In homologous series, you will see one important point, that between the two adjacent carbon, either we take this first, second we take, or second, third we take, third, fourth we take, any two adjacent carbon, we will see there is difference of CH2. There will be always difference of one carbon and two hydrogen. And CH2 group is different. You can see here, and if you will see here also, you will see C3 and C2, out of which one carbon is extra between the two, and along with that 2 hydrogen is here. So whenever you will use, you will see whether you are using it for alkane or alkene or alkyne. Each time you will see there is a difference of CH2 group. Not only that, you will find that the atomic mass of the difference in atomic mass between the two adjacent, whatever molecule you are taking here, you will find that there will be difference of 14 atomic mass unit. 12 atomic mass of carbon is 12, and then along with that you will see 2 of that of hydrogen. So total will be 14. Okay, and with this, one more important point that you have to remember is that having the same formula, the chemical properties will remain same, because suppose the alkane we are talking about, all the alkanes will have same chemical properties because they are having same chemical formula. Alkenes will have same chemical properties because having same chemical formula, and similarly with alkynes also. The only difference will be in their physical properties. Physical properties varies as we go down